Okay, welcome back to the part 2 of the week 3. Okay, so in the previous part, we talked about the problems of the cell arrays, and we were talking about some kind of magic that can expand the space in between two stored elements, and then I told you that we can enable that by using the linked list, and we are going to discuss that in this part. Okay, so before we start, there is a detour. Detour means that it's kind of circumvent. We have to go fast to make things a little bit faster, right? It's slower but faster way. What we are going to recover at this moment is the reference class. This is the reference class. And value class, okay? And here, the value class doesn't inherit handle, and this reference class inherits handle. And this means that inherits object in the MATLAB world. And without the handle not being a reference, what happens if it is a value case? And the next slide tells you what happens. So we instantiated two classes, one with handle, and the other one without handle. And we created cell array here, right? And then when I print out the status, it says the loop color is red and door is closed. And loop color is red and door is closed because these are the default setting. At where constructor. And then what I do is that H1 paint loop green and H2 paint loop green, calling the same method. Right? And then neighbor 1, which is supposed to store H1. So this is H1 actually. And this is supposed to be H2, but I will put question mark here. Anyhow, so when I say that H1, when I reference it to H1.print status, the loop color is changed to green. Here, still the color is red. It's not changed. This instruction didn't impact this, right? This instruction really impacted this array. And then H1 print status is green and H2 print status is red, right? H1 is actually equal to neighbor 1. Answer is 1. It's not, right? So it means that H2 here stored things stored in the cell array here supposed to be H2 question mark is actually not a H2. This is definitely H1. We verified that here. What happens? The difference between the handle more like reference class and the value is this. So we have neighbor cell array, and H1 is what being stored in the cell array is the handle, right? Like its reference where it is, right? This where it is information is stored here in cell array. Any change in this box will be reflected to here. So any change here happens here. What happens in the value case? So this is the value class, and whenever it is assigned to cell array or other place, the value is copied. So this thing and this thing is completely not linked. Any change here happens here. it's not being reflected here. So that's the reference case, and this is the value case, right? Without handle, MATLAB always leaves the original value untouched. With handle being reference class, MATLAB always stores and touches the single variable memory space. And this is the reason why all these things happening. Okay? Remember that. And we are going to use this knowledge in the next few slides. So, coming back from the detour, what we were talking about was the linked list. Base structure looks like this. So we are going to construct a singly linked list with nodes and references. Nodes consists of a variable to hold reference to its next node and variable to hold a reference to its own value object. If we draw the UML class diagram, things will look like this. So there is a node class, and there will be a reference, a holding area, holding variable, calling the next named next node, right? Like this. And then you will have the whole variable called value of the node, right? And there are special nodes, head and tail, right? And then this head doesn't have value. Means that it's not going to be a new class, rather the value will be always not assigned. And this is a special case of node. The next node will be always not assigned. Okay. In between these two cases, these are regular nodes. And these regular nodes, this next node part is represented like this, and this A value is represented like this. Same thing happens. This next is represented like this, and this B is represented like this. Okay? It's kind of hectic, so I will just change the ink color a little bit. So this A is going to be in the value, and B is going to be in the value. And next we'll hold this whole class instance. Sorry. And this next will hold this whole instance as a value like this. Okay, so this is a small diagram. And actually, let's see as a code. Let's see the implementation of the nodes class, right? So we have member variables. We have these properties, right? And this set access private means that outside of this class, access to these properties are not available. So this means only be used by this dot something in this class dot m file, right? So besides of this is the whole thing same properties. So we have property object value that we discussed and node next that we discussed. And this node pref, this is for the doubly linked list, but it's here. Let's ignore this for the moment. And we have this Boolean head and Boolean tail. This indicate whether this is a head or not. Same thing here, indicate tail or not. Okay? And the methods are this. We have, of course, this special method called constructor here. And we have all these values, get value, set value, and next. This node's next. And set next. This node's next. Set. So this node will come in as node next, right? And this object value can be any value, right? And is head, whether it is head or not, and set this is head. Is this a tail or not? And set this is a boolean, and asking whether it is a tail or not. This B should be capital B, right? We have the member variables, we have member functions. And this is an actual implementation of the previous, this class diagram, right? And we have this class diagram here, so I'm going to erase it for the moment. All right. Oh, okay, this works fine. Great, the eraser works fine. And let's see, change it the mode. And we have this node class, we have these properties, right, here. We have these functions. And the thing is that because it holds node as property, and it's one by one relationship, it means that one node has a node, another node as what? The next node. Okay, that's what this class diagram tells you. And we have this special node called head and tail. So we have this head and we have this tail. If we don't have no regular nodes, then it's empty linked list, right? Head always at the first of the list, tail always at the last of the list, and these two are the kind of cornerstones showing the start and the end of the list. By knowing where the head is, we can access to this linked list. Okay. And these are actually the optional nodes. Linked list, it can work okay without head and tail, but the coding becomes quite tricky, right? So we just want to add these two in between these regular nodes, right?